Hi, I'm Elaine. Welcome to my podcast channel.
Hi,
Hi.
Andy. Could you please introduce yourself about your professional field, your major, and what you teach in general?
Yeah, I'm Andy Lawrie. I'm a professor of math at MIT in Massachusetts,
Mhm.
and I study what's called mathematical analysis
Yep.
and partial differential equations.
Oh, that's really cool. So what is mathematical analysis? Could you elaborate on that a little bit?
Yeah, so in uh, I guess of the high school class, so there's kind of three uh, main branches of math, I'd say. Um, One branch is algebra and number theory. So algebra, like your algebra classes in high school, and number theory means the study of the typically the study of the whole numbers, the counting numbers 1, 2, 3, 4, 5, 6, 7, and questions about numbers, so classical questions about numbers. Um, and then another field is geometry and what's called topology, and it's roughly the study of shapes and how things are curved and things like this. And then mathematical, and then there's analysis is the other branch. And this is if we're relating to high school classes, this is most similar to the calculus classes you take in high school. And I study what are called partial differential equations or differential equations, which are uh, uh, um, it's the study of how things move in nature, for example, um, uh, like if you throw a ball
Mhm.
and watch its trajectory, you can see how fast a ball moves or its trajectory by solving a differential equation. And there's lots of things in nature that are modeled by differential equations, and I study the solutions to these equations. So or how waves propagate in space, or how the planets orbit around the sun, things like this.
Oh, wow. So it's sort of like how people need some math modeling basics to like build mo rockets and
Yeah, there's differential equations in basically all facets of life and science, and and so I try to understand the mathematical properties of solutions to these equations.
Mhm. So basically, you are working on math and practical applications, and it's not
Yeah,
your
yeah.
math.
I'm a pure mathematician. Um, so the meaning the questions I ask are mainly interesting to other mathematicians, and so interesting because of the math itself. Um, and there are tons of applications for differential equations. Um, but
Mhm.
but the things I study day to day don't have immediate applications to something in the world. Maybe to some theoretical physics, but loosely. But we, as a pure mathematician, we're interested in sort of the math itself and in building the mathematical theory behind these equations. So when when there is something in nature that comes up, we have a mathematical theory to understand it. Uh,
Mhm.
Things like this. So it's not so much about the applications, but more about building the theory. Um,
Oh, so math modeling and sort of
yeah,
getting set up.
and yeah,
Mhm.
exactly, and building. So there's the things we're interested in usually have some physical motivation, and so there's a
Mhm.
and so the equations come from some physical model, meaning physical model meaning um, something that modeling something that happens in nature. Um, but then it, it's you want to develop a theory that applies to many such models.
Yep.
And so you try and find the mathematical structure underlying these models, so we can understand a lot of different models, not just one particular model, but a lot of different models that have common features and things like this. So I try to build that theory rather than work on a particular application.
Right.
Particular application. That makes
Regarding
sense?
Yeah, that is really interesting.
Oh, yeah,
Might
that, but
might do some. I'm always like, I might do some math modeling in the future. Maybe that
yeah.
is something that really benefits the society. I think
Oh,
it's a
for sure.
really,
Yeah,
really good thing to do.
yeah,
Yeah. I'm curious about what is your daily like life as a
yeah. As
mathematician at MIT like because you have
yeah.
students and then you're really busy.
Yeah. So, I think a typical day during the semester, um, so I teach a class usually, it happens twice a week. The classes are typically an hour long, so I spend 2 hours in the classroom typically, or maybe 3 hours in the classroom
Mhm.
uh, a week, and then a little bit of that time is spent preparing for the lectures that I give.
Yes. How
Um,
much time do you spend preparing in general?
So usually it depends on the class, so it depends on how familiar I am with the subject or how many times I've taught it in the past.
Mhm.
But I'd say for something I've taught a few times, probably I spend about an hour preparing to teach an hour lecture.
Mhm.
And then the rest of my time I spend doing my research. And so that's a bit more open-ended. So I spend a lot of time just thinking about the problems I'm studying, and they when I write a paper, it typically takes 6 months or so. So they're kind of long-term projects, and most days I
Mhm.
don't have much progress on it. So a lot of time thinking, a lot of time trying to learn math. As a like professor, you never sort of stop learning. There's so much math that you have to keep learning. So
Right.
I keep trying to learn math. I learn what other people do. And then I spend a lot of time also talking to other mathematicians, like we're learning from, collaborating with them, talking to each other, teaching each other things. So typical day, I wake up, go to my desk,
Mhm.
um, think about the current thing I'm working on, hopefully for a couple of hours,
Mhm.
teach a class, and then get back to thinking about my research project for another few hours. I like to have big blocks of time where I can think, like 3 hour blocks of time where I don't have anything to do and I just kind of think about what I'm working on.
Oh, so it's thinking like I find it really funny how when you go to a university and you see professors just staring blankly at the white like I don't know whiteboard or
Yeah, yeah.
chart and then I had a friend who said that, "Oh, I initially thought that they were stupid or something,"
Yeah.
but it's
Oh, no.
actually really quite the opposite. They're
No,
really
we feel pretty. I mean, I think as a mathematician, you feel pretty stupid all the time. It's like it's like the research takes a long time, and the way I make progress is by making a lot of mistakes,
Mhm,
and thinking about it the wrong way. And then if I flesh it out, then I realize, oh, this was a dumb way of thinking about it. And but then I learned, oh, that was a dumb way of thinking about it. Let me try something else. And so you do spend a lot of time just kind of going down wrong paths and stuff. But yeah, it's a bit different from working in high school, or even taking classes when you're in college, which are, you have to do homework every week or every day, and you have to
right,
turn over very quickly,
mhm,
and I spend a lot more time being stuck and not making any progress. So it's a bit different type of time scale for which you solve a problem. It takes some things take years to figure out. Some things I still haven't figured. Sometimes I've been thinking about for years. I still don't understand. So you have to
mhm,
kind of be you have to kind of be willing to be stuck for very long periods of time. Or
right.
stubborn, I guess, is maybe the right.
Right, so it's so different from high school how you're just given a lot of problems and you solve it, it's
You have to
done.
solve them. Yeah, you solve. Yeah, like, so it's a big shock. Kind of, you're used to solving problems right away, and or if you're taking a class and it clicks at some point, and you can figure out you can do the problems. And at some point, it's much more common to not be able to solve the problems for long periods of time, and that's kind of okay. It's your
Mhm. Is it
um,
frustrating sometimes to just be stuck every single day on this problem?
Oh yeah, oh for sure. Yeah, it can be really demoralizing. Yeah, to be stuck for long periods of time, and it's one thing that you kind of have to. It takes a long time to get used to that feeling, and I think when I first started out, I would have these highs and lows where I'd be, if I would feel like I made progress one day, I would feel really excited, and the next day I would figure out everything I did was nonsense, and then I would feel really depressed for a couple of days. And
Yeah,
and so I've
roller
kind of learned to
coasters.
not, yeah, roller coaster. So I've kind of learned to be more, or still learning to be more even keeled about things and not try to get too high or too low.
Right.
Yeah.
For example, you written something like, oh, you thought you solved this problem or a big problem, but the next day when you wake up, no, this is just really trashy.
Oh, that happens all the time. Yeah,
Yeah.
yeah.
So do you keep it with you or you just throw it all out? So do you document your progress?
Oh, yeah. So, I've I've also learned to try and keep things because um, so I try to write things down, um, and um, even hold on to things unless it's complete nonsense, of course. But
Mhm,
but I so one time I was in I have a one kind of extreme example of this is
mhm,
I was in graduate school, and when you're in graduate school, you have an advisor who's like it's like you're an apprentice sort of to your advisor. It's your teacher, and he or she,
mhm,
you spend a lot of time with them, and they give you your thesis project and things like this. And at the end of graduate school, I was working with my advisor on a problem, and we thought we had solved it, and we even wrote a paper. We wrote the whole paper, and then we were very happy. We went home. It was like we finished it on a Saturday in his office, and then we both went home. And then um, uh, he went to a concert, I think, and during the concert, he realized that he thought he had like the inklings of like a counterexample to the thing we thought we had proved,
mhm.
and he called me in the next Sunday, the next day, and we came to his office, and sure enough, we built a counterexample in a few hours. And we realized that the whole paper we wrote was just false. And so he like printed it out. He was so mad, he printed it out and threw it like physically threw in the garbage. So he like tossed it. He's like, "This is trash," and threw it in the trash. And so we were quite upset, but it turned out that a few weeks later we realized that we were wrong for a good reason, and then we it being the way we were wrong helped us then understand the right way to approach the problem, a few months later we had a paper we were really proud of. But
Right.
yeah, but we thought we were very close to just uh, declaring that we had solved a problem, and it was complete nonsense. Yeah, our solution was complete nonsense. So.
Right. So sometimes failures lead to success, especially in math, how you just have to try, you have to
Yeah,
go to the idiotic space and then you can develop
yeah,
something
yeah,
interesting.
yeah. It takes a lot. Yeah, it takes a lot. Yeah, I think every single project I've worked on, I've uh, 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 had been you're wrong about many aspects of it
Mhm.
over and over and over again, and finally, like all these failures, help you get to the right understanding. So it's a and it yeah. So I think most mathematicians I think would tell you that they spend most of their time just being wrong about things, and then eventually, like hopefully like once or twice a year, you
Yeah. Yeah.
figure something out. So
Mhm. Yeah.
yeah, but definitely you have to kind of learn to um kind of live with your failures and sort of learn how to be wrong in a good way, where you're kind of stumbling towards something, and learning from the things you got wrong.
Yeah, for sure. So, according to so many papers that you've written for the past few years, what do you think was your most successful math project that you felt like, oh my God, this is so good?
Oh, um, I think my most successful project was last year in 2021.
Mhm,
My collaborator, Jacek, Jandre, uh, and me, we solved something called the soliton resolution conjecture,
mhm,
um, which is a problem about what what waves look like. Um, if we watch them forever. So if we watch waves until the end of time, what happens
mhm,
to the wave? And there was a conjecture that people had worked on, a bunch of people had worked on many years, and we managed to solve it in a case that people cared about, and that was I think that's my my best my best work.
Mhm.
Yeah.
Sort of like the Fourier analysis or something.
Is it involve Fourier analysis?
Yeah,
Yeah, it certainly does. Yeah. It definitely involves Fourier analysis. Yeah.
yeah. Yeah. So regarding high school students' problems,
Yeah.
I think that a lot of people, my peers, are suffering through math, or not a lot, but I think they just aren't that passionate, or
Uh-huh.
they suffer through school math problems. Do you think Googling like answers for math problems is a good way to study? Or
Oh,
yeah,
yeah. I do that all the time, actually.
okay.
So yeah, if I can't figure out, I try and figure out things, but but I if I can't figure something out, I'll like look up something on Wikipedia, or try and figure out if someone else has thought about
Mhm,
the same problem before. Um, I kind of think that it's really important to struggle with a problem.
mhm,
Like if you're given a problem and you just like Google it on the internet and just look at and look at the answer, but not ever struggle with it, then it's probably hard to like get a deep understanding of things. Um, but um, I definitely think like if you're stuck on something for a while, it can be really helpful sometimes, especially after you've thought about a problem,
mhm,
to get some help, and like the internet's a great place to get help. Or if you have other like if you once you go to university, you'll have and study math, there'll be other students and things. So it's a great idea to talk to your peers about things. I do this all the time too. So another way to, aside other than looking on the internet, I'll ask my friends if they've ever thought about a certain problem, if they have any idea about how to do it, or how to understand it. I think that I think looking things up is totally fine, but only once you've spent a while thinking about it yourself.
mhm,
Does that make sense? Like,
for sure.
yeah,
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 so it's really important, especially doing math problems. It's really important to have this self-thought process before you
yeah,
just, oh, I don't know, I'm gonna look
yeah.
it
To
up.
start Googling, yeah, exactly. But if you're stuck and if you don't understand, I think it's a great idea to to seek help. And Google's a great resource for that. Yeah.
For sure. Yeah. Uh, for yourself, do you think you are like for some mathematicians, I've heard that they like to draw things like
Uh-huh.
geometrically, and some just like to write letters or numbers,
Formula. Yeah, just like
like
yeah.
relationship. Which one do you think is the best way to present your idea?
Oh, I'll present ideas, or to try and understand things. I think I do a bit of both.
Mhm,
I it's helpful for me to try and think of a good picture to have in my head about what's going on. So I think that if you like look at if I'm talking with some other mathematicians, and
mhm,
you look at our board afterwards, it's going to be filled with pictures, for sure, of us trying to explain things in pictures to each other. Um, but in my field, sort of, there's pictures, but the pictures, you also have to nail things down, with formulas and equations and inequalities and things like this. So for me, it's kind of, I don't think there's an either or. It's kind of a healthy dose of both. Having a good picture in my head, but then also using that sort of picture in my head to try to nail things down with formulas.
mhm. Yeah, I think that that's a really good suggestion because especially if you're presenting ideas to other people who aren't specialists in
Yeah.
that particular field, do you think pictures would
Oh, definitely.
illustrate it better?
Yes. Yeah.
Mhm,
So pictures, and I think another a good way to present some ideas, and this takes a lot of work to I mean, we're always still trying to refine this, is to think of a kind of a simple if you have a problem that you want to describe to someone, if you try and think of the simplest version of this problem that still contains some of the essential features of it. So kind of strip the problem of what are the kind of unnecessary complications, and give a kind of toy version of it first. So
mhm,
that can be quite a challenge to think of a good toy version of the problem that you're working on, or easy version of the problem you're working on, that sort of contains the main ideas that you need to, that if you understood the main ideas to solve the toy problem, then you'd have, with some more work, possibly more technical work, the ideas to solve the harder one that you're trying to present. So,
Right. I totally agree. I mean, in high school, math, I
yeah,
think they focus so much on calculations, but
yeah,
theoretical proofs.
yeah.
Which one do you think is more important? Like, do you think the calculation part is important, or more on your thought process and theoretically proving something?
So I think I'm a pure mathematician, like I was saying
Mhm.
earlier, and what characterizes us is that we try to prove things. So that's what our job is. So for us, writing a rigorous proof is the goal. Um, so, but again, like sometimes it's my answer is I'm gonna hedge and say both things are kind of important,
Yeah.
uh, or pretty important. Uh, like to get to the place where you have um, uh, a proof, you often will need to do some calculations. And so I think what the emphasis in high school is often on these calculations, just to sort of build technical strength, so
Mhm.
that and it's what's hard is that it seems like these are like a lot of pointless kind of exercises to do.
Yes.
And that's kind of, it's kind of unfortunate if it comes away, if it comes just across as pointless exercises. Um, where I think if you're really successful teaching the class, you try to convey, like, okay, we have to do become competent in doing these calculations, because we're trying to
Mhm.
understand this concept. And if you understand that, and so you have an idea in mind, the concept in mind you're trying to understand, and you have a good motivation for suffering through the computations. um,
Mhm.
and I think what happens in high school, and I remember this too, is
Right.
it feels like just endless, boring computations. And why do I have to do 20 of these same problems like this? And it's yeah, it's not great. So
Mhm.
um, yeah,
Were you really good at math back in when
I
you
don't
were?
think so. I don't think I was that. I didn't. I don't. I was okay. I was always pretty good at it. Pretty decent at math. I
Mhm.
wasn't. Uh, I didn't go to math competitions or anything like that when I was a high schooler. So wasn't. I didn't know that I could be good at math really until I went to the university, and it was only towards the end I started. I was like a history major,
Oh,
and
wow.
yeah, I was a political science major, and then I was an economics major. I was trying to find what I liked, and I kept on
Right,
changing.
right. Yeah.
And then I took some economics courses, and then in order to take higher level econ courses, I had to take some math classes too, and I ended up just
Mhm.
really liking the math classes. And then, even though I found them challenging, I sort of kept going, and at some point, um, I liked them so much that I spent a lot of time trying to learn, and I got better and better.
So
Um,
passion and interest is the key.
Yeah, I really think it's interest, and yeah, exactly just like you said, passion and interest, and it
Mhm.
took me a while to figure that out. But then once I did, I spent a lot of time trying to learn math. And I think it's a bit hard to tell um, if you're good at math, because it's a lot bigger than the math you see in high school. So the field is a lot bigger.
Yeah.
And like I was telling you, those kind of three, or there's another field also called mathematical logic. It's a classical field. But these fields like algebra, number theory, geometry and topology, and analysis and PDE,
Mhm.
they're quite different from each other.
Right.
And like the people that are good at algebra aren't necessarily don't necessarily like analysis in the field. Or
Yeah.
I really struggled in my algebra classes and didn't understand what we were doing, and I could never really figure out what was going on. And so
Mhm.
I think you can uh it's it take it's even it's really it's hard to say like, oh, I'm bad at math, because there's just many, and in geometry topology, like there are some, topologists who are just really good at visualizing things and thinking about things, and this really this ability to have clear pictures of things in their head, um, makes them amazing mathematicians. And so people, I think mathematicians have a wide variety of different skill sets,
Yeah.
and so it's really hard to say. Like I think it's not so. Um, it's probably. Um, I think people are probably too quick to say like, "Oh, I'm not good at math," because
Right.
there's so many. Maybe you're good at one area of math, or better at one area of math that you don't even know about yet. And, I think that was
Right.
kind of the case with me. I didn't know I was good at math sort of until I found the area of math that I liked, and spent a lot of time studying it. So
Right. Especially from a history major to a math major, they're completely different diverse
yeah,
fields.
yeah, yeah,
Hmm.
yeah. Yeah, so it's kind of and I'm not unique. Like there's a lot of people, a lot of mathematicians I know didn't know that they were be mathematicians until
Hmm.
much later. Some knew all along, sort of, but there's mathematicians are pretty diverse in terms of like our backgrounds and our training, early training and things like this, and things we thought we were good at. So
Yeah. So, did you have an advisor who inspired you into this mathematical field? Like,
yeah,
into
for sure. Yeah, yeah, a couple of them. And I had some. I think that when I was an undergraduate, I had a professor, a couple of professors I took a bunch of classes with. I liked like a first class I taught, and so then I took whatever class they were teaching the next time. So I had a couple teachers when I was undergraduate I thought that were
Mhm.
really inspiring.
Yeah.
And I think like I sort of was narrowing in on my field, the
Yeah.
field that I kind of liked, the general field I liked after I finished my undergraduate.
Mhm.
And then in graduate school, my advisor um, uh, was, I mean, incredibly inspiring, and I just learned so much from him. I would go to his office on Fridays, and
Mhm.
I'd walk out just completely energized, because he would have showed me all. He would start with me at the board, and I would show him what I was thinking about, trying to understand that week, and then eventually he would take the chalk from me and show me some new stuff, and I
Mhm.
try to understand that. So he was yeah, hugely inspiring for me. Um,
Right. So, when you say you're trying to understand a theorem, do you mean you want to know why this is derived, like their derivation?
Yeah. Yeah, like so why it's so you try and understand. So there's a lot of things you try and understand. Or we can, but like for, yeah, exactly like you said. So try and understand why a theorem is true. And then also oftentimes it can be challenging to um understand the proof, and then even if you understand sort of the mechanics of the proof, like what like how like you understand every line of it,
Mhm.
it can be, you might wonder like how did someone think of some things can seem kind of mysterious. So like how on earth did anyone ever think of this type of thing. So you want to understand like why, how someone might come up with this type of argument. And with experience you sort of learn, oftentimes learn uh, um, not just like how to write these arguments, but uh, um, but see where the idea, kind of see where the ideas came from, and that was, it was really important to have a good advisor for me to help me through this, trying to understand why a theorem is true on the one hand, um, and on the other hand, how someone would have come up with with a proof of this.
Yeah. Speaking of coming up with proofs, just a
Yeah.
curious question. Have you thought of your own idea or like new idea for your thesis out of like say that you were having coffee and then suddenly you just had
Oh,
this
like like eureka moment or things like this. Yeah,
yeah,
yeah, yeah.
yeah.
Um, yeah. So yeah, there's definitely been moments. I think I remember the sort of I think I thought of the key idea in my first like my thesis project um, when I was in the shower. Um, and right,
Yeah.
and
Mhm.
I distinctly remember that moment. But on the other hand, um, I also remember many. So I guess I said you have many kind of eureka moments, but I think 9 out of every 10 of them are end up being wrong. So,
Mm.
right, so yeah, I've had some moments where it turned out that it ended up being
Worth
right,
a
but then
shot, like, just
yeah,
yeah.
I I have some other memory of I was taking a walk one day and I thought I had this great, amazing, idea, and then a few hours later, or the next day I gave it a try and it was just complete nonsense. So, but that night as I was walking, I was quite sure I'd come up with something amazing. So, yeah, you might have some eureka moments, but you have to. This is the roller coaster I was mentioning before. Some of them end up being complete nonsense. So, um, yeah, yeah, for sure.
Yeah, I was wondering also for, like, I guess a lot of students wanna know, about percentages at high school versus university, like, universities, is it hard to even get, like, a 90 above? Like, I've heard from all of, like, other people, they were, like, saying, if you get, like, an 70 or 80, that's, like, a really good score. I mean, it depends
Yeah,
for different people, but what's your
it
viewpoint on
it
that?
depends on it depends on the class, but I definitely had classes like that when I was a student where, um, like there's a exam out of 100 and the average score on the exam was a 30 or something like this. Where most people got, you know, basically got the everything wrong. Um, and yeah, I remember being horrified after I took an exam. I think it was a midterm from one of my classes, and it was out of 30. And I remember just being terrified afterwards. There were three questions, and I felt um, and I knew I got one of them, and just one of them I couldn't get. I just left it completely blank. I couldn't figure out anything, and then
Mhm,
the second one I sort of got some part of it, but not the whole
mhm,
thing. I got a 15 out of 30, and I got the score, and I was just completely shocked. I was like, it was one of the first hard math classes I took, and then
mhm.
afterwards it turned out that was a great score. so,
Yeah, actually, like the curve, right?
so yeah, so it depends. Maybe so. What happens is especially when the classes involve proofs, the test can be too hard. The professor may give a test that he or she thinks is at a good level for the class, and it ends up being a little bit too hard, and a lot of people can't get don't get a very high score. So that aspect can be discouraging too, right? But I I it, I yeah, it depends. It depends on the person teaching the class. There's a lot in the university. There's the person teaching the class has a lot of, especially for the upper level classes. There's a lot of discretion involved in what the exams are like, what you teach, and yeah. So it's sometimes it happens where even if it's
Mhm.
not the intention of the professor that the scores are a bit lower
Yeah.
than you imagined when you were writing the test. Um, so.
So how do you really solve the problem of getting, like, at the
A good grade and things like this. Yeah.
yeah, yeah.
I think is it so usually for the upper level classes or classes where this happens, there's much more in the semester that you do aside from say the exam. So you have weekly homework that you do,
Mhm,
and where you don't have exam is tricky because you have an hour or something
mhm,
to write a proof or something. And you might just blank, and it's not really like I was saying before. The time scale for like research that we do is like year long problems or things like this. Where in an hour, like if you gave me an hour to do anything in the day, I wouldn't be able to. Be able to do it. So oftentimes exams like this aren't necessarily the best way at even capturing as students, a single student's understanding of the material. And
mhm,
so, even if a class has hard exams, you want to make sure you do the homework every week and keep trying to understand. And as you get through it, just that week, the consistent work every week, um, you'll give yourself a pretty good shot in the tests. Um, uh, but again, I think we all know that sometimes the tests aren't. don't give an accurate portrayal of the student's understanding. And so there's always a bunch of different components of a grade in a class.
I'd say never give up to
Yeah, you have to keep working. Yeah,
high
exactly.
school.
Yeah.
Just keep
Yeah,
going.
if you just, I think the best strategy is just to consistently do the work every week, and not in math classes. I think that's especially important that you don't there's a tactic where you can just cram for the exams right before them, and that ends up being really challenging because a lot of math classes at university are cumulative, where
Yes.
so you have to, you have to keep, the stuff that you're learning in week 4 relies on the stuff that you learned in week 1, and then by week 12 it's relying on.
And the hardness level is like just exponential growth.
Yeah, so you just have to keep up with it, or else it can just kind of pass you by, and it's really hard to catch up. So I think that's the best strategy, is just to keep just consistent work. Carve time out during your week, where every week you're going to spend this amount of time, 10 hours per week on this class or something like this. Or something like this, yeah.
So once a high school student, they graduate and they're going to university and doing mathematics, they should be spending time on math like consistently, instead of, okay, I have a test tomorrow, so I'm going to study 4 or 5 hours today. And
I would say I would block out some consistent time period. Everyone's different, I think, in the way
that
you
works
learn.
in high school to a certain extent, but not in university.
Yeah, I think it depends. Again, it depends on the person. But yeah, I think it's I had a classmate who used to say, like, oh, it's kind of treat it like a job, and if you take 4 classes at university, you're gonna have to want to work at least 40 hours a week on these classes. So you kind of devote 10 hours per class, per week or something like this. This is where I came up with the number 10 hours per week on each class. And then you sort of divvy that up, I think, in the way that makes the most sense for you. Maybe 2 hours, 2 hours a day or something, and on each class or something like this. Or you spend, or if you like, long periods, maybe you spend 4 hours on, one day in a class. And the thing about university too is you take fewer subjects than high school, so I think that you get to
2 courses, right? Or 4?
Yeah, usually I think typical load is usually 4 courses, about 4 courses, 3 or 4 classes.
Yeah, so time management, a lot of different portions. Like, it's at university, it's sort of like independent.
Yeah, it's much more independent. So you have to sort of make your own schedule, and it takes a while to figure out what works best for you. But I think, just and whatever it is, it's like, so staying up to, consistent with your class, with your classes, is a good idea. So making sure you're working on every class every week.
Yeah, about MIT, what do you think is the significant or this spike of the MIT math program that is so very, quite different from other math programs, you think?
I think there are a lot of students that come to MIT that are interested in math, and so I think that it's one aspect is just bigger than other math programs in the sense there are more math majors, uh, and more
Also more
students.
popular, yeah.
Yeah, so it's just quite a popular major at MIT. Where I didn't go to MIT as an undergraduate. I went to Columbia University in New York, and there were just a fraction of the math majors at Columbia that there were at MIT. So I knew every math major. And there were, I think, my year there were 6 or 7 of us who wanted to go on to graduate school. Whereas at MIT, there's 5 times that amount every year. I think 50 students or something that want to go to graduate school every year. So it's quite a bit bigger. And but as far as the instruction you get, MIT is a great place. There's great faculty there, but there's great faculty at a lot of universities, and we're all pretty comparable, I think.
Yeah.
So I think there's a lot of really strong students, so your peers will be really strong at
Mhm.
MIT. And there'll be just a lot of them, and so it's you'll find it'll be easy to find a lot to find if you're interested in being a math major. You'll be able to find a lot of friends who are math majors because there's a lot of people that are math majors. So it's easy to find groups of friends and things like this, people to talk to that share common interests. But as far as like faculty or instruction, I don't think it's any different than 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 most of the research universities. I think we're all all have pretty comparable faculty in terms of especially in terms of instruction.
What do you think about MIT's vibe? Is it a lot of people are really nice, or are they more formal and serious regarding faculty?
No, the faculty. Oh, I think it's pretty informal. And I think it's a it's a pretty nice place,
Mhm.
pretty nice and welcoming place. And the students too. I think it's a pretty eclectic group of students always. So a lot of people with a lot of different interests and a lot of different types of people. It's a very diverse student body. Um, yeah, I find it to be a really um, uh, welcoming place. Although I have to say that there's a it's pretty common. It seems to be a common issue among undergraduates that there was a lot of could be a stressful experience because there's as I was saying, it's great that there are a lot of math majors or a lot of students. Just this like focusing on the math majors, but
Mhm.
um, on the other hand, it can feel kind of overwhelming that there's so many other good students, and a lot of students that come there, really good students in high
All
school.
over the world, like
Yeah, and
top.
then you arrive, and then there's a bunch of other people who know all as much as you do and more, and it can be quite I think there are students who feel um it can be that aspect can be a bit overwhelming.
Mhm.
Um, just the sheer number of really really strong, well prepared math students. I think of it when I was as I said, I kind of wandered into being a math major,
Yeah, yeah.
and I think it was a bit better. I was maybe fortunate that I wasn't that it was a smaller group of math majors at my university. Um, it was a bit easier to enter into that group. So
Mhm.
um,
Yeah, also another curious question. I noticed that especially this doesn't really happen in other classes, but in high school, students are the teachers want their students to write everything on the whiteboard
mhm.
instead of on a notebook. And also, I think in some universities as well, a lot of students solve problems on the whiteboard or blackboard. Why?
Yeah.
Why do you think
Why?
this happens? Like, why?
I don't know. Well, like I find like the Blackboard or whiteboard is great if I'm talking to somebody else. Um, eh, just like we can both stand and stare at the same at the
Yeah, yeah.
same surface. But I don't think there's anything magical or mystical about it aside from just its usefulness as a way to for two people to look at the same thing at the same time. Two or three people to look at the same thing. Whereas
Mhm.
if you're in front of your notebook, it's sort of a personal thing. So I mean, when I work by myself, I work with a notebook or
Yeah.
paper and pencil. But then often when I'm talking to someone else, we'll write at the board because it's just easier to communicate that way.
Mhm.
Both stare at the same thing. Um, sort
Right.
of.
So, do you think that in math, presenting your ideas using just a PowerPoint is better, or you have to write things down and have the process of writing things down and then explaining? What
Um,
method do you prefer?
I prefer the writing method.
Right. Yes.
I find it a lot. I find it hard to. We go to seminars or listen to other people talk about their work, and I find it. Unless the speaker is really talented with a PowerPoint type presentation,
Mhm.
um, or at explaining things with it, I find it a lot. Easier to follow if it's happening at the board, for example, or someone's writing something down. Just because I think it tends to go slower that way. Maybe it's
Mhm.
sort of constrained by how fast you can write. So rather than clicking through slides where it can sort of, and then once a slide goes and it's gone, and I don't remember what was on the previous slide, and whereas at a big bunch of blackboards, I can look back and see what you were writing 5 minutes ago or 10 minutes ago.
Right. Yeah, that makes sense.
Yeah.
Yeah. What was, because I've online, I search things up,
Yeah.
and I actually searched you up and saw one of your videos,
Oh
explaining
yeah. Oh
mathematical
no.
concepts. It was amazing.
Okay.
How did you feel when you were presenting your ideas? Were you nervous?
I'm always nervous. I'm a pretty shy person, so
Mhm.
I always feel a bit nervous when I'm speaking in front of people.
Yeah.
And it's unfortunately it's never gone away. So
How many
yeah.
people were there sitting?
I'm not sure which video you watched, but it depends. Sometimes you give a lecture and there are 10 people in the audience, sometimes 50 people in the audience. So some things like this, and then teaching classes, sometimes there are 300 people in the audience, or so things. It
Yeah,
just depends.
prepare a
But
lot and then write on a paper so you don't make a single mistake. Otherwise, 50 or 100 people will hey, that's wrong.
yeah, no, that definitely happens. So it definitely happens. But yeah, you try to be well prepared uh, and kind of know what you want to say, so that you can, or that's at least what I like to do. I like to kind of think about what I want to say for quite a while, and then so I can just present. And I try to forget that there are people watching me.
Yeah.
That
What is the method of forgetting there's people watching you? Because there's
I think that's another reason why I like writing things on the board when I'm giving a talk, is I can if
turn
I'm
your
doing
back and
I
write things
am doing
down.
something I'm just doing something active, and so it kind of calms my nerves a bit to be writing rather than just standing and staring at the screen.
Mhm. Yeah, I think that's a really good idea. Are you planning on giving extra talks around the world, like online or whatever?
Oh, it- uh, we always, that's part of our job, is to go, like, when we have something that we write a paper or something like that, we often go into to seminars and explain to our friends colleagues at different universities, uh, things that we've proved. And so that the way we do that is we go and we give a talk, and then and people listen to the talk.
Mhm. Yeah. So another question regarding, I noticed that AI and computer programming and all this technological or scientific development is progressing
Yeah,
through human civilization or whatever.
yeah,
Uh,
yeah.
do you think mathematicians would speak? Do you still need mathematicians if we have this
Like
robot and
computer
programming?
assistants, like if will
Yeah,
computers replace
yeah,
mathematicians?
yeah. Can computers
Yeah,
replace?
I kind of I sort of feel strongly that the answer is no.
Yeah.
Uh, but I think there's many things that it's there's always kind of amazing things that computers can help mathematicians with. So I think it's more probably a future um, where a human kind of works with a computer to understand something. And there might be some aspects of an argument that a computer do, but I think I'm a bit skeptical of the computers replacing human mathematicians. Like if the game of if math is about proving theorems,
Mhm.
I think computers can help that, but I don't think that they can uh, think of the theorems that they should be proving, kind of.
Yeah, I totally agree. Humans are more creative and computers and programming, it's more on following a set of rules and designing and
Yeah, there's an aspect of art of math that's like it's a bit like art, and it kind of it's that aspect of it that if a skeptical computer um can understand what's good. Like you sort of know what's good art when you see it, sort of, and same kind of about math. Like it's more than just I don't know, there's uh, some beauty in math that I find it hard to believe a computer can
there's
capture.
yeah, there's definitely beauty in math.
Yeah.
probability,
Yeah.
testing probability of your next flip or
Yeah.
in your next coin or dice or whatever.
Yeah.
Do you think that with so many mathematical equations and all this math and calculations, do you think humans would one day be able to predict the future?
Oh, uh, I don't think so. Um, I don't know. Like, maybe, I think it's really hard to. We're pretty good at like predicting the weather, but even that's really hard. Like, we see
Mhm,
like a big storm coming somewhere. It's really hard to understand
mhm,
where, with high accuracy where its trajectory, like where it'll lead, things like this. I kind of think the universe and the like the Earth and the world and everything's so complicated, such a complicated dynamical system that it's sort of it's very and chaotic that it's quite hard um, uh, to think about how predicting the future would go. Um,
mhm. Too many variables.
too many variables. Yeah, exactly.
Yeah,
Too many variables. Yeah. Yeah.
yeah. That's so that's really, really true.
Yeah.
Yeah, and also, regarding math, of course, do you
Yeah.
think, as you mentioned before, at the very start, there are so many branches and like from
Yeah.
these three main categories,
Yeah.
are there branches of math that just stop developing because it's not necessary to investigate further through or
For
into?
sure. Yeah. Yeah. And then there's also areas that where it becomes kind of sort of all the problems become are understood, and these areas sort of stop, not because it stops being interesting, but rather that it people sort of figured everything out that there was to figure out.
Mhm,
um, and so there's like kind of areas that are more active than others at different times. um, Not just about in there's is what people are interested in, but also like whether or not and there are other areas where the problems become just are so hard that no one has any uh, reasonable expectation of making progress, and so people tend to not work on those areas as much either. So there's many ways in which a sort of a field can sort of be or a smaller field can become dormant for a while, or not just that it becomes uninteresting, but maybe all the problems are solved or the problems become too hard or
mhm.
things like this. But yeah, for sure, there's kind of branches that sort of die. Um,
Yeah, yeah. So, which branch, even though you mentioned a little bit at the beginning, which branch and what specific little idea are you, or you can give an example, are you really interested in?
yeah, so I work within mathematical analysis, and so the equations I typically study at wave propagation. So so what are called wave equations, and the thing that I'm interested in, the type of things I'm interested in is so a typical wave, let's say when you shine a flashlight against a wall,
Mhm,
then the light spreads out. And if you back up away from the wall, the light spreads out into a larger area and becomes
mhm,
dimmer, right?
mhm.
And there's an analogous example. So you drop a pebble in a pond,
Yeah.
and the waves ripple out from where the pebble fell in. And as the waves that are farther away, they um, they're covering a large radius, and they're smaller
Mhm,
than the waves than they were when the waves were covering a smaller radius. And this is because there's wave equations conserve energy. So as the wave spreads out, the energy has to stay the same, and so the amplitudes of the waves decrease. So this is called dispersive behavior of waves, and you see this when you're
mhm,
shining light against a wall or when the pebble falls in the pond. But there's but if you allow things to interact with each other, waves to interact with each other, so this is called what are called nonlinear effects. Then you can have these kind of atypical wave phenomena, where rather than energy spreading out and dispersing like typical wave
mhm,
behavior, there could be clumps of energy that stay together.
mhm,
And I don't study this, but an example in nature are black holes, where the in astrophysics, where there's a clump of energy that comes together, and it doesn't disperse like gravitational waves. And there are examples in water. They're called solitary waves, just a wave that keeps its shape and travels across the ocean without decaying. And so I study these atypical wave-like behavior. This is like we call them, they're called solitons. This is the name we give them, where they're clusters of energy that don't disperse, that they stay together. And the questions I study are this like stability properties of these. So what happens if these clusters, they're very special type solutions. Waves like to disperse, and so something special has to happen to have a wave that doesn't disperse. And so then you ask, if I poke it a little bit, or if I start off close to it, what happens if I let time run? Do I keep this cluster of energy, or does it all break up? What happens if I run two of them into each other? Do they collide and become dispersive waves, or do they sort of pass through each other or bump off each other and stay coherent? So these are the types of questions I'm interested in.
It sounds really profound, and
I don't know about this.
wow, lots of terms to know.
So that's
professional.
math is it's like a language you have to learn, and I shouldn't. It's unfortunate if I used a lot of terminology. I'm sorry about that.
No, actually, I
but
really like hearing about these terminology. Like,
okay.
I think it's just wonderful to hear. It's
Okay.
music, and then even though you can't really understand what's going on, but it's wonderful to
Sort
hear.
of understand. Okay, great.
Yeah.
Okay.
Yeah, sometimes I'm even thinking to attend these math talks by professionals such as you. Even though I can't understand anything, but the feeling, it's just great. I'm like
Good.
trying to be smart.
Yeah, no, well, not being able to understand anything is pretty common. So I often go to talks where I don't understand much of anything that goes on. So it's it's fairly common.
So, envisioning 100 years from now or 1,000 years, what changes in the math field do you expect to happen?
Oh, like I said, there are too many variables, so I'm too cautious to make any predictions. Yeah.
Related to number theory, which is quite debated right now, do you think that these hard problems might be solved in the future by someone?
These kind of old conjectures in number theory. Yeah, sure. Like the Riemann hypothesis is the big, and I mean, I don't know. At some point, I wouldn't be surprised if someone proves it. Not that.
Do you think you might prove one day?
Oh
when you're
no, I don't think so. I don't think so. Yeah.
Yeah.
You have to be quite yeah. Yeah. I don't think so.
You have to be a genius or whatever. So
you just have to. I mean, maybe you have to devote 20 years to it or something. Which is quite a scary endeavor. So you could devote 20 years to it and make no progress, basically. So.
Wow. Yeah, especially find it really disheartening. Like in movies, there's like professors who worked on a problem for 30 years, and there's a student who just looked at it overnight because he's a genius and he solved it.
Yeah. Good Will Hunting, right? Is
Yeah.
That's no, that usually so that some things like that happen, but it's not very typical. Yeah.
Yeah. So do you think you need a specific like this genius portion of you to be good at math specifically?
No, absolutely not. Yeah.
Really?
Absolutely not. I think I I I think that it's more just uh patience, hard work, and even people that display these like genius type qualities or prodigies, right? Or young age, I think is solving a big problem just takes a lot of work and dedication. So it's not necessarily the genius, I think, that solves it. It's the hard work and dedication that gets you there. So
Yeah.
I think most I don't think mathematicians. You talk to mathematicians, I don't think they'll say like, "Oh, I'm a genius." So, I,
Maybe it requires some little portion of, creativity and genius.
I think everything requires some some and I mean I'm taking any field like this, a spark or things like this, but
Mhm.
but I think it's really hard to define genius.
Right.
Yeah, and like I said, I think there's mathematicians are if you look at just a group of mathematicians, they're so diverse, and in the way we think and the way we approach problems, things like this, that I don't think there's one kind of type of person that's good at math, for example.
Yeah.
Yeah.
Mhm.
Yeah.
Similar to your history, which you studied probably first year, did you find any similarities between your study methods between like the arts, like history and math? Are there any like
Did I? Yeah. eh, did any of my earlier interests like help me?
right, right. Any
Uh, I, th- yeah, I don't know. I mean, I liked reading a lot. And so maybe the reading is a quiet activity, so I enjoyed which is, and math is often a quiet activity, so maybe those things have in common. But I'm really not sure. That's a good. So I'm gonna have to think about that.
Thank you so much for answering my continuous
No,
and
this is
broad
great.
questions
Great
and
questions.
answering and doing your best to answer all my questions. It's
I
great.
I really enjoyed it. Yeah.
Yeah, okay. Thank you.